All right, so far we've been looking at exponential functions all week. Okay, a couple things we've done with them. One thing we learned how to do is if I give you a table, how you get the A and the B value from it, and you write a formula. Another thing we learned how to do was graph. We didn't review it in the warm-up, but what are the x values that you usually pick when you want to graph it? First, how many do you pick? Yeah? Yep, you pick 5. And what are the x values we normally use? Yeah?
-1, 0, 1, 2.
Yeah, we use those numbers because if you start using numbers that are a lot bigger, the graph is going to probably curve off your paper very fast. So those are the values we pick. So we've done writing a formula, writing a graph, or drawing the graph. What else have we done? We also looked at some formulas for word problems. So we looked at the one for compound interest. So if you're going to make a reference sheet for this week's test, that's probably a formula you want to put on it. And then the formula we did right before that, which was the 1 plus r to the t. So we had that formula, and then we had the one that had the exponential growth, compound interest. Okay, so let's go, just reminder one more time, what's the formula that we use in general when we're writing an exponential function? It's the one, it's that main one that we've been using all week. Yep, y equals a times b to the power of x. And when you're writing a rule from a table, Tirza, how do you get the a value?
Whatever matches up with 0 in the x column.
Yep, so you look at where the x column will have a 0 in it. You look at that, and then you look at the number that's in the y column. Right? So it's what the y value is when the x value is 0. And how do we get the b value? Someone remind me how we do that?
Figure out the pattern for the y column.
Yep, you got to figure out the pattern, and the pattern has to be what operation to be exponential? Yeah? Has to be multiplication. If the pattern was addition, like you did plus 2, plus 2, plus 2, that's not exponential, that's a straight line. Okay, the pattern has to be multiplication. Okay, so it's what the y value is multiplied by each time. All right, so let's practice actually what I just said. If a table is a linear table or an exponential table. Remember, if it's linear, the pattern in the y's is going to be addition or subtraction. If it's exponential, the pattern will be multiplication or division. Okay. So we're going to identify whether a table represents an exponential or a linear function. And if it does represent an exponential function, we're going to write the formula. Okay, the y equals a times b to the x. All right, let's look at this one. So example 1a. Those are the x values. -1, 0, 1, and 2. Is that enough information to figure out if that represents an exponential function? What do you think? Yeah?
Yes.
Well, we're missing half the table, right? What are we missing that I haven't shown you yet? Yeah?
Y value.
The y values. The whole key is if something is exponential, you have to be able to look at the y values and figure out what you multiply by each time. If you don't know the y values, you can't figure that out. There's your y values. Okay. Does anyone think they see what the pattern is in the y values for that one? Yeah, I see. Yeah, you are multiplying by 3. So if you're not sure with the fraction, you could always take your calculator, type in 1/9, hit times 3, and 0.3, repeating, that is 1/3. Then you could take 1/3, multiply it by 3, and you get 1. And then if you take 1 times 3, you get 3. So since we're multiplying by 3 each time, is that my A value or my B value? Yeah, that's my B. So B is 3. And what's my A value? Yep. A value is 1/3. So it says if it is an exponential function, write the rule for it. Okay, write the formula. So what would be my formula for this one? Actually, we got a line down below. We can write it on where it says rule for function. But what is the formula before we get to that line? Yep.
Y equals 1/3 times e times 3
Times 3 to the
times
just to the x. Yep. All right. So let's put that. You guys have a spot in your guided notes. So the rule for the function is 1/3 times 3 to the x. Okay, so there's the rule. And can somebody tell me why was it exponential again? Why wasn't it a straight line where we would use like y equals mx plus b? Yeah. Because the y is being multiplied. So is this an exponential function? Yes. Y is multiplied by 3 each time. That's the key. Pattern is multiplication. Any question on it? All right. Why don't you guys, let's look at this one. So take a second and see if you can figure out if that one is exponential. And keep in mind, if the y value is getting smaller each time, you might be multiplying by a fraction. Right? You multiply by an integer like 2 or 3, it's going to get bigger each time. This isn't getting bigger each time, so you might be using a fraction for what you multiply by. So see if you can figure that one out. Okay, so first thing you could try to figure out is say, all right, well, let's see if the pattern is adding or subtracting. If it was subtracting, how do you get from 4 to 1? Yeah? You would subtract by 3. So if the pattern is subtracting, then we should be able to subtract by 3 again to get to the next number. So 4 minus 3 is 1. Is 1 minus 3 1/4? Yeah? No. So then the pattern is not subtracting. Okay? That's not. All right? So then the only other thing it can be is multiplying. What do you multiply 4 by to make it a 1? Yeah? 1/4. Yes. And we can check that by taking the number 4 and multiplying it by 1/4. And we get 1. Now let's check it here. What if you multiply 1 times 1/4? What do you get? Yeah. Yeah. And that's the next number. And if you multiply 1/4 by what we think the pattern is, 1/4, you would get 1 times 1 is 1, and 4 times 4 is 16. So the pattern here is you are multiplying by 1/4 each each time. And if you get stuck and you can't figure it out, one way to do it, take this number and divide by this number. Or basically take any number and divide by the one that comes before it. If you do that, it should tell you what the pattern is. So take any number and divide by the one that comes before it. So in this case, 1, and then divided by 4 is 1/4. And that's the b value. Okay, so is this an exponential function? Yes. The y's are multiplied by 1/4 each time. Okay, so now we know it's exponential. Can somebody tell me what they got for the rule for this one? Yeah?
Y equals 1 to the power of x.
Yep. So y equals a times b to the x. There's your a value. It's the number below 0. And there's your b value, 1/4. And that's the answer. Okay. So, what was happening to the y values in this one? Were they getting bigger or were they getting smaller? Yeah? They were getting smaller. Each time they were getting 1/4 as big because we were multiplying by 1/4. What happened to the y values in this one? Yeah? They were getting bigger. They were tripling each time. So whether the values are getting bigger and bigger each time, or getting smaller and smaller each time, there's a name for that. And that's what we're going to put at the bottom of your guided notes. So it says on the first bullet, if a table represents, you want to write in exponential growth, then the y values will increase. Growth means increase, means they're going to get bigger. How much bigger? Well, it depends what you multiply by each time. But as long as you multiply by a number bigger than 1, that will cause them to get bigger each time. So in the last problem we did, we multiplied by 3 each time. And that caused the y values to grow. Okay? So that's called exponential growth. Now the other case you can have is if you don't multiply by a number greater than 1. You multiply by a fraction, like 1/3 or 1/4, like in the last problem we did. That's called exponential decay. So exponential decay is when the numbers go down. They get smaller and smaller and smaller each time. And the reason they get smaller is because you're multiplying by a number between 0 and 1, like 1/4 or 1/2 or 1/3, something like that. So decay, think about what something happens when it decays, right? If you put like a bunch of leaves in a pile in your yard and leave them there, they decay. It means they break down. They get smaller. There's not as many leaves there if you wait 5 years from now because they decay. They break down. Okay, so decay means it gets less and less over time. It doesn't matter what the a value is. When you're looking for growth or decay, you're looking at the b value. So let's say we had 5 times 2 to the x, and y equals 3 times 1/2 to the x. Which one of those would be growth? Any one of them, yeah? The top one. Because the b value is 2. So this would cause your numbers to double each time. This bottom one, what do we call that one? In this case, the b value is between 0 and 1. That's called, yep, this is decay. This is growth. That's decay. And the difference when you sketch them, that one looks like that. It grows, it goes up. This bottom one goes like that. It goes down. So growth, decay. Okay. Right, so let's flip over to the back of your guided notes. So at the bottom of the front, we explained what happens if a table represents growth or a table represents decay. Now, we're going to explain what happens if not a table represents growth, but the actual function itself, the formula. And it kind of ties in with what we just said about the table. So on your guided notes, in the first blank, you want to fill in what's in bold, exponential growth. And what I'm asking you is, what kind of number has to be in that red box if you're going to have a function that's growth? Yeah?
Number that's bigger than 1.
It's got to be bigger than 1. Yep. If you put a number that's greater than 1, that's what goes in the blanks, there's 2 of them, that's greater than, then you already have the word than written, and then fill in a 1. Okay. So now the second bullet says, for an exponential function to represent decay, what kind of number has to be in that box now? Yeah?
Smaller than 1.
So look at how it's worded on the guided notes.
Less than 1.
Between what?
Between 0 and between 0 and 1.
Yeah. So it says on the guided notes, between, and it has to be 0 and 1. So examples of numbers between 0 and 1. 1/2. 2/3. That's between 0 and 1. If you take 2 and divide it by 3, that's 0.6 repeating. So that's between 0 and 1. 0.75. Okay. Those are all examples of numbers between 0 and 1. Most of the time it'll be a fraction, but you could see a decimal. It's okay. You could see that. All right. So now, example 2. Let's just look at some formulas. And all we're going to do is write one word. Growth or decay. It's going to be one of those two. Y equals 0.54 to the x. So focus on the 0.54 number. Is that going to be exponential growth? Or is that one going to be exponential decay? Yeah? That's decay. Yep. Exponential decay. Why is it decay? Because the number here is between 0 and 1. Okay, and if, we don't have to do this, but I can just show you. If you were to graph that on the calculator, 0.54 raised to the x, it's going to curve down as it goes to the right. See how it curves down? That's decay. Growth would be the opposite. It would curve up. Okay. How about that one? Y equals 3.0221 to the x. Is that exponential growth? Or is that decay? Yep. That's growth. Yep. And again, there's no reason you have to sketch it, but if you just want to see what that one would look like, 3.0221 raised to the x. This one is going to curve up as it goes to the right. Okay, see how it curves up? That's growth. Red is the growth, blue is the decay. All right, how about this one? 0.993 to the x. Growth or decay?
That would be decay.
That's decay just barely. It's just barely decay, because if it was bigger than 1, it would be growth. But that's still less than 1, so it's decay. It's going to be a very slow decay, but it's decay. So any questions on example 2? All right, so let's try 3 and 4. So 3 and 4 is a review of what we've done earlier in the week. 3 is a graph, and 4 is a compare. So you're going to write like vertical stretch by factor of, or vertical stretch and reflect over the x-axis. Okay, let's try example 3. Now, just by looking at the formula, you should have an idea if it's going to go like this or it's going to go like that. What kind of graph is that? Is that the growth or is that the decay? And let's call this graph 1 and let's call that graph 2. Yeah? Yeah, this is decay. This is going to look like graph number 2. If it looks like graph number 1, you did something wrong. That's growth. Okay? All right. So we're going to make a graph. And how many points do we need to put? I don't think you guys have a table, so I would just write off to the side. Don't go into example 4, but just on the side, make a table. And how many points do we generally pick to make the table? Yeah? Yeah? Do 5. And let's put the x values that we're going to do together, and then I'm going to let you guys do the y values, and I'll get out some calculators for you. Okay, what are the x values that we're going to pick? Okay, I told you, you can pick anything, but the problem is if you pick numbers that are too big, you're going to go way off your graph. You're going to be like up at the ceiling, so you don't want to go too big. Yep. And what are we going to do? We're going to have to do it 5 times. What are we going to do with each one of those x values and this formula? Yep. Yep. We're going to plug each one of these numbers in for x, one at a time, and see what we get. Okay, so I'm going to pause it, and you can use a calculator if you need to. You just need a calculator that can do exponents. So try to plug all 5 of those numbers in, one at a time for x, and then see what you get for y. Okay, and if you get your table, then try to graph your points and see what your picture looks like. Okay, so we picked our x values, and now we need to figure out the y values. Okay. What's the first x value that I need to plug in? Yep, -2. So on my calculator, this is how I have to put in a fraction. I'm going to put 1/2, just like that. Hit my exponent button, and then hit -2. And I get a y value of 4. Okay, so there's your first y value. What's the next x value I'm going to plug in? Yep, -1. So what's nice about this calculator is if I'm going to have to type the same thing in over and over, I can press a button that brings up the last thing I typed in, and all I have to do is change the thing that I want to change. If you have to retype it every time, it's not a big deal, but it just saves a little time. So 1/2 to the -1 gives me 2. Okay, how about 0? We shouldn't need a calculator for that one. Anything to the 0 power is what?
1.
It's always 1. And if you look at the y values, you can kind of start to see a pattern as to what's happening. Okay? You're multiplying by half each time. So it's getting half as big as it was. Right. What's my next x value? Yep. 1. So we could type it in 1/2 raised to the 1. Except I forgot a parenthesis. Well, if you raise anything to the first power, it stays the same. So it's just 1/2. Or you could put 0.5. And what's my last x value I need to plug in? Yep, 2. And what did you get when you plugged in 2? You got 1/4. Did anybody figure out what is 1/4 as a decimal? 1/4, that's like a quarter, right? Think about what it would be in cents, a dollar. Yeah? 0.25. Now, the reason we don't pick numbers bigger than -2 or smaller, let's say you pick -5. You can try to pick -5, but watch what happens if you plug in -5. You got 32. Do I have 32 grid marks on that graph? No, I don't have that many. So that's what's going to happen if you pick a number that's either too small or too big. You're going to go right off the graph. If you pick -2 to 2, you'll probably be okay. Right, let's graph it. How do I graph -2 to 4? Okay, starting at the origin. Yeah. Yep. Left 2, up 4. So there's your first one. How about the next point? -1, 2. Yeah. So left 1, up 2. Okay. The next one, 0, 1. Brady, how do I graph that?
0, 1, go to 0 on the x. So, with all the lines intersect in the middle, and you go up 1.
Yep. Okay, so now I think we're starting to see a curve a little bit. Emily, how would I graph my next point?
You go to the right 1.
Yep.
You go halfway up.
Yep, go to the right 1 and go halfway up. Okay, so now it's starting to get a little close to the line, so it's hard to kind of make it perfect. And then the last one is right 2, and then 1/4 of the way up. Your line should never go underneath, like down below. It should always stay up above in quadrants 1 and 2. All right, so make your sketch. Just kind of draw it like that. It does keep going in each direction. As it goes further to the right, it just ends up getting flatter and flatter and flatter and flatter, but it will never go under that black line. It'll just get closer and closer and closer and closer to it. Any question on the sketch? All right. So now we've done sketching with exponential decay. We've done identifying from a formula if something's exponential decay. So now let's do a compare problem. Comparing with exponential decay is exactly the same as exponential growth. You don't write any different sentence. You use that vertical stretch by a factor of, and then you just write your number. So let's try this one. So the first one is y equals 3 to the 1/2 x. And you're comparing it to 1/2 x. Okay. What's this 3 going to do? What would be the sentence that you would write that describes it? Yeah?
Vertical stretch by a factor.
So vertical stretch by a factor of, can you just say what the factor is again? 3. Okay, so what does that really mean? Well, let's say this was your original graph. You did something like that. Okay, that's a decay graph. If it's going to be a vertical stretch by a factor of 3, then it's going to do something like this. going to take that graph. Actually, it's not going to let me. Let's see if I can do it on this one. Nope, won't let me. What I was trying to do is just stretch it vertically. Maybe if I trace over it. Okay, that worked. So there's the original. This is a vertical stretch by a factor of, well, it's probably more than 3. But the point is, it makes it stretched out vertically. Okay, so that's that one. And let's look at this one. Y equals negative 1/3 times 1/2 to the x. Okay, what's going to happen in this one? Just tell me the first part. Yeah.
Vertical stretch by factor of 1/3.
Okay, so let's start with that. Vertical stretch by factor of 1/3. And if we stretch by 1/3, can someone remind me again, what does that really mean you're doing? Yeah? Right. So this is what your graph looked like. Let's see if I can do it on this one. If you stretch it by 1/3, that means you need to make this box 1/3 as tall. Okay? So it would, well, let me do it. I don't want to change both at the same time. I just want to change one of them. Let's see if I can do it this way. So take that. Yep, I can do it. So make this box 1/3 as tall. So if it's that tall, I don't know, maybe that's 1/3 as tall. That's a vertical stretch by 1/3. It really compresses. And what else is happening besides the stretch? Yeah?
You have to reflect over the x-axis.
Right. We have to reflect over the x-axis because of the, what's telling you to do that?
The negative.
The negative. And reflect over x-axis. Okay, so that part's exactly the same as what we learned before, even though we're doing decay now instead of growth. Okay, so that finishes up 6.364 part 3. Homework tonight is a worksheet on Schoology, and tomorrow we'll wrap everything up with part 4. Just a reminder, I will be after school tomorrow if you need to make anything up before progress homework.